Let's talk about the case one. The highest jump rate will be the salute atom jump in vacancy, which means that they have strongest binding energy. They like to jump back and forth between the like to exchange site. Then the second will be the host atom surrounding by salute jumping vacancy, and the slowest one will be the host atom jumping vacancy. Under this situation, what's the DS, diffusivity for this salute atom? So this is the one I just explained that the vacancy is binded with salute atom, so for a relatively long period of time. So jump rate, you can consider like 10,000 jumps per second, 100 jumps per second, and 1 jumps per second. So based on these assumptions, we know that they like to stay together, like they prefer to stay together. And the slowest one will be host atom jump in vacancy. Under this situation, we need to figure out which jump will drive the salute atom really diffuse. This is a key point. So let's have a look. I did draw some figures to help you to understand which step or which jump is the dominant jumps to drive this salute diffuse through the structures. So we have salute vacancy and host surrounding salute. They like to get together and jump back and forth, right? But after 10,000 times jump, probably will have 1 jumps between vacancy and host nearby salute. But before I have these jumps, actually the salute did not really diffuse or moves, right? They just move back and forth. But after like a 10,000 times of jumping, probably we have one time of jump between the host atom with vacancy. So I will have a vacancy here and host atoms nearby salute here. Then following, they like to stay together. So following like a 10,000 times, jumps back and forth. But still at this moment, salute atom did not moves or diffuse, right? Slightly when you jump to here. Okay. Then next, probably next will be when salute atom move to here and vacancy move to here. Under the situations, probably we will have the other like host atom nearby salute jump in exchange site with vacancy. So I will see the V back to here, and host atom nearby salute will be here. So the following time is like used to like exchange the location for the following time period. Then at that moment, you see that the salute move to right-handed side. So it turns out that the salute really diffuse, but the major reason is not due to the non-gamma prong between salute and vacancy, right? Actually, the limited step who drive less jumps, salute really diffuse due to the quite important movement or jumps is due to the host atom nearby salute jump or exchange site with vacancy. So this will be the limited steps. Based on this idea, in order to persuade you like this like pairs, because we have the salute and vacancy have strong like attraction, right? So you can have the other point of view. If I have like a group them was here, was here, was here, was here, and really moves. Okay, so this will probably will be more visible, more obviously. But anyway, It turns out the faster one is not a critical limited step to drive solute diffuse. Actually, is the middle one, gamma prime solute, host is a nearby solute exchange site with vacancy. So based on this one, I know the limited probability or limited step is this one. So the diffusivity for the solute binded with vacancy, we use a star B, is equals to dominate by gamma prime V as, which means that the host is a nearby solute exchange the site with vacancy times the alpha A. Alpha A here is a geometry factor. Geometry factor actually is related with the crystal structure. Okay, so it turns out the solute diffusivity, this solute is binding with vacancy one is proportion with gamma prime Vs. And the important information is here. It turns out gamma prime SV, which means that the solute exchange with site with vacancy one has no contribution to the solute diffusion. They jump back and forth, nothing contribute with this solute diffusion. So, but my question would be the solute diffusivity, not solute binding with vacancy, it's a solute diffusivity, would be solute diffusivity binding with vacancy one times the what? You need to know the x, the fraction for this pair, right? So it's some kind of xv dvf, xi dif. So this is x, okay? But this x is the solute binding to vacancy. The probability you have will be including the vacancy, this vacancy binding with solute, and also this vacancy formation gives the energy. So you have two, like a formation and all divided with vacancy. Okay, and this is in, and also the ds star b will be copied here, but the more important parameter I want to highlight is we have 12 here. Some people don't know why probability, and we also extra need to times 12. So I'm going to use one slide to persuade you. Because in vacancy mediated one, we just use XVDVF, right? But here we use with XV vacancy binding with solute. We have 12. Why? Due to the vacancy now is binding with solute. Everything is due to here. So I showed these pictures. This is in crystal. This is like I try to draw similar one, but this is in 2D plane, right? So I try to use this in FCC structures. This is a loop, and I have 12 possibility. Have a vacancy. Vacancy can be one of out of 12, any one, right? So 12 is due to here. If, for example, if I pick this one, I bind it with this one, and I want to show you what happened here in 2D, but here in real structures. So if the solute binding to vacancy, the vacancy is this one, but have 12 possibility, right? But if this one, then the host data nearby solute will be, after like jump back and forth, after like a certain time, this will jump into vacancy. Host agents nearby solute jump into vacancy, then solute vacancy will become here. So also they jump back and forth. So this pair was here and now here. And after like they also exchange site for a long time because of strong attraction. Then at one moment, solute here, vacancy here, and the host agent nearby solute exchange with jump into vacancy. So this pair now will be here, moves, right? And also at this moment, if the salute back to jump here, then other host agent nearby salute will, oh sorry, the other one probably will be here somewhere or jump into vacancy, then this pair will be moves. So you visualize this pair, salute vacancy pair moves, right? But this is just one possibility. If you try to find the salute binded with vacancy, you probably just find one pair, but you have no idea which directions, which one was it. As long as it's not this one, it's this one, then they will diffuse to others wheres. 所以在这里有一个重要点是说，为什么会有这个是因为他们是一对，但你找到有多少对这件事情，它可能就这一对，但你不知道这一对是这一对还是这一对，但每一对它接下来它扩散的移动方向都不一样，所以其实你有12个方向，就是因为他们是一对，然后有12种可能成一对的方式。那我这边画的就是这一对的话，那它就会移动，经过一系列之后，它就移动到这里。但你可以想，那如果这一对是这一对，那它就会有它自己的，所以你有12对，所以这里的12是这么来的。好，希望可以帮助你理解12的来源。Then let's move to case 2. The only difference just the order between these two. The highest gamma prime will be the host agent nearby, surrounding salute, exchange the site with vacancy. And the second one will be the salute and vacancy one. And the slowest one also is a host jump exchange with a vacancy. And in this case, we also follow the same logic. We also need to find a limited step. So I also draw the figures as time increase. As we remember, the highest jump rate here would be the make host agent nearby salute will be the green one. But we also, as we assume we have a salute vacancy pair always like stay together. Okay. So I have a vacancy nearby salute. But now the jump rate here will be the highest one, so which means that the host near surrounded by salute will jump in vacancy. So it turns out it's like make a circle. This jump to here, vacancy will be here, and this will be jump here. So it's like circling behavior. But even though they circling after 10,000 times jump, the salute still stay here. Nothing contribute on the salute diffusion. But after certain time, to where when the vacancy will be on the right-handed side of the salute at this moment, then okay, that would be sorry. So would be like circling, right? But after certain time, the salute and vacancy exchange the site. So the salute will be here, vacancy will be here, so it will be like this. And the following time, they also circling the host agent surrounded by salute will jump into vacancy. This will be junk, so also circling behavior. So the salute really moves due to this, right? Salute vacancy exchange site. So the same idea. Circling have no contribution for the salute diffuse. But when the vacancy will be here, somewhere they will to move to left-handed side. Then they exchange the site. So at this moment, we will find the salute become here, and the vacancy will be here. And also, then next will be circling again. So it turns out the salute really can diffuse is due to the gamma prime SB, which means that the salute exchange side with vacancy. This is a gamma prime with middle rate, gamma. not the fast one. Okay, so the limited probability will be the solute exchange the site with vacancy. So it turns out the same idea. The solute diffusivity for the solute binded with the vacancy is equals to alpha b gamma prime SV. Host atom surrounded by solute exchange with vacancy. Also, sorry, so it's a solute gamma prime solute exchange. I mean solute exchange with vacancy because this is limited step. And for the solute diffusivity, also the same idea. XV, dV, dXV, d ds binded with vacancy, then times 12. So the same idea. XVS and 12 is the same one I just addressed that. For here also vacancy formation, you need to have vacancy, and this vacancy should bind with solute atom. Okay, so this will be the last part for vacancy mechanism. Here is you have a substitutional dopant replace the host atoms at the substitutional site, and the solute diffusivity can be shown like this: 12 alpha 12 gamma prime exponential, and his inside you have a vacancy formation and gives free energy and vacancy binded with solute atom. But here, compare these two. Diffusivity both belongs to vacancy mechanism. This is belongs to host atom, and this is a host the solute diffusivity. Compared to these results, we know that this vacancy, I also can separate this Gibbs free energy into the enthalpy term, and the gamma prime here can be will contribute the migration enthalpy. So compare both these terms, we visualize that they have the vacancy formation, migration are the same, right? But this term, we have extra term, which is a vacancy binded with solute atom. As we mentioned, they have a strong attractive and force, which means they have a this means that they like to together, right? It will be negative energy. So this is a negative term. So inside exponential negative term here, we have a small value compared to this one. So here I will have a higher solute diffusivity compared to this one. So let's tell you, this will explain why people have a substitutional dopant. This dopant can highly increase the diffusivity, okay, of this solute atom. OK，这里的话就会很明显，就是我把刚刚的那个 这个 solute 的，就是solute atom 的 diffusivity 写出来，然后我们把它变成 exponential term，因为其实在 diffusivity 里面常数其实影响不大嘛，那 exponential term 很容易 dominate，所以我就把它们换成不用 Gibbs energy， 我用 enthalpy， 然后把那些 entropy term 放在前面，那我用正比的方式，那就可以发觉说，在 exponential 负的这里面，跟 vacancy mediated 其实有两项是一样的。这 gamma prime 的话就 migration， 两项一样，然后这边有一个vacancy binded with solute 这件事情，我们刚一开始假设的时候就说它其实是一个negative 的 body energy。因为他们两个有吸引力，就是一个 negative， 所以那是个减的一个值，所以减完之后，这个值一定会比它小。这个 exponential 里面比较小，这个值就比较大。这也解释了为什么很多人的置换，他就是他会选择不用有些的取代提高它的一些光电池的特性是用取代型的置换，就是 substitutional dopant， 因为这样的 dopant 它的 diffusivity 会比较好。那它就会光电池的特性就会比较好，这是就是解释为什么。